అవును సార్.
ఎవరు పేరేంటి ఇంతకు?
ఆయన పేరు
Okay, welcome back to next session. This is Krishna HOD of Zoology, Vasudi College. Now let us start continue topic of sericulture. Mulberry silkworm is completed. Now Tassar silkworm we discuss it. Okay, please mute yourself. Please, ma, don't disturb, please. Okay, so that is, you know very well, Tassar silk. What is Tassar silk? Tassar silk is generated by, okay, the silkworm, that is, and the silkworm scientific name, that is Antheria millita. Antheria millita. This Tassar silkworm scientific name, remembering one thing, Antheria millita, M-Y-L-I-T-T-A, millita, which is mainly thriving on the food plants, Assan and Arjun plants. Which plants? So these Antheria millita silkworm, Tassar silkworm, which is living on, okay, which plants? Assan and Arjun plants. Which plants? Assam and Arjun plants. Okay. Next, it is less, remembering one thing, it is less lustrous than mulberry silk, but has its own feel and appeal. Okay, so then compared to mulberry silk, this Tassar silk is a very important thing, lustrous. It is very weak than compared to mulberry. Clear? Remembering one thing. It is Tassar silk is mainly produced in the states. Already told you, Jharkhand, Chhattisgarh, and Odisha, and besides Maharashtra and West Bengal and Andhra Pradesh also. Okay, mainly northern states which are producers non-mulberry silk. Already told you, right? So mainly this Tassar silk mainly produced in the states. What the states, ma? One is Jharkhand, one is Chhattisgarh, one is Odisha, and one is Maharashtra and West Bengal and Andhra Pradesh. And Andhra Pradesh also. Clear? No. Okay. Now, this Tassar culture is a mainstay for the main tribal community in India. Okay, especially for this culture, Tassar culture, which is there in the agency areas. That means tribal community areas. Okay, social tribal community areas, especially for this Tassar culture, will be observed. Okay, next one, oak silkworm. Okay, oak silkworm, you know very well, it is a finer, that means a finer variety of Tassar generated. So it is simply this oak Tassar silkworm. It is similar to same family of Antheria millita. Okay, same. That's why it is a Tassar generated by the silkworm. Right. That is, it is generated by Antheria proili. Antheria proili. So it is a nothing but scientist, James scientist. A scientist was introduced this plant, this silkworm. That is J means scientist. J means scientist. In India, they feed on natural food plants of oak. Natural food plant of what, ma? So oak plants. Remembering one thing. So found in abundance in the sub-Himalayan belt. Sub-Himalayan belt of India, covering the states of Manipur, okay, Himachal Pradesh, Uttar Pradesh, Assam, Meghalaya, Jammu Kashmir. Especially for the seven sisters, like eastern countries, the eastern Himalayan countries, which are that means Manipur, Himachal Pradesh, especially Assam, Meghalaya, and these are the eastern countries which are produces this Tassar silk, and Uttar Pradesh, okay, and Jammu and Kashmir also, which are produces this Tassar silk. Okay, China is the major producer of oak Tassar. China is the major producer of the oak Tassar in the world, and in this comes from the another silk which is known as, okay, that is one more tussar silk also there, the China tussar, that is specially for China tussar silkworm, that is called Antheria perni. For Indian tussar scientific name Antheria proili. Antheria proili, remembering one thing. So this Antheria perni, which is to produce a huge amount of the tussar silks from the China. Okay, that is you observed the diagram in tussar silk. Okay, oak tussar silk. Now let us coming to the point. See, Erie silk worm. You must be observing the diagram Erie. Okay, this is the Erie silkworm. It is also known as Indi and Erandi. Okay, the Erie silkworm, it is also known as what ma? Indi, Endi and Erandi. Okay, Endi, Endi and Erandi. It's simply we can call it. Okay, why this Endi and Erandi? Nothing but it is a especially for northeastern states. This word we can call it this Endi and Erandi. We can call it in northeastern state like. North state, eastern states like Assam, Meghalaya, Arunachal Pradesh, so etc. It's a different sisters which are we can call it ND and RND. Okay. Erie silk is a product. Erie silk is a product of domesticated silkworm. Domesticated silkworm. Okay, not the wild type of silkworm. Okay, so that Erie very important worm scientific name, that is Philosamaya. Okay, but that means Philosamaya resini. Philosamaya resini. That means the resinous plants. Resinous communicate because of especially for these silkworm to eat only resinous. That means castor leaves. That feeds mainly on castor leaves. In Telugu we can call it amudam. In Hindi we can call it amudam leaves, right? So it is called ericulture is a household activity. Ericulture, that means production of Erie silkworms. That means rearing of Erie silkworm for the production of Erie silk. That is called ericulture. Is a household activity practiced mainly for protein-rich to farm and delicious of the tribal. Delicious of the tribal, so that's very important. Here, okay. I think next the silk is used that means indigenously for the preparation of that means what happened now. So that is chadars, that is wraps for own use by the tribals. Okay, the silk is used indigenously for the preparation of chadars like wraps for own use by the tribals, especially for this Erie silk. Culturing for only tribals, especially for in which northern east states, already told you. In India, this culture is practiced mainly in northern eastern states and Assam. Northern eastern states, nothing but you know very well. Okay, Sikkim, right? Sikkim, Arunachal Pradesh, Himachal Pradesh, okay, and Meghalaya, okay, and Assam also. This the Erie silkworm. We should be culturing. Now, last one, Muga silk. Okay, what in Telangana and Andhra we can call it. Okay, it is Munga. Okay, Muga silkworm. Muga obtained from the semi-domesticated multi-volatile silkworm. Muga obtained from the semi-domesticated multi-volatile silkworms. Multi-volatile silkworm, nothing but if the what is a volatile and multi-volatile? Volatile and multi-volatile, nothing but so if the silkworm in the whole lifespan to give only one crab, if the silkworm to give in the whole lifespan only one crab, that is called that means only mono-volatile. Okay, clear? But so these Muga silk is it means in lifespan, in the whole lifespan, they produces number of crabs. Number of crops, more than 3, more than 2, that is called multi-volatile silkworm. That is a special of milk, that means silkworm, that is Muga silkworm. Okay, the Muga silkworm scientific name, okay, Antheria assamensis. Antheria assamensis, because of it is, especially for these silkworm, industry which is located for the Assam state. That's why it's called Assamensis. Okay. So which color of this Muga silkworm? The Muga silkworm, this is a golden yellow color silk. This is what, ma? This is a golden yellow color silk, is a prerogative of India, in the pride of Assam state. Muga, nothing but Muga silk industry completely located at what, ma? Especially for Assam state. That's why it is a one of the pride of Indian, the pride of Assam state for the production of, that is especially for Muga silk. Okay, that is for the main employment, main agriculture, that is in only especially for this sericulture, Muga silkworm in Assam state. Right. Muga silk culture is a specific to the state, that is Assam. Muga is equal to Assam. Assam is equal to Muga. That is especially completely whole, and 70 to 80% of the employed people, they are depending on this production of silk, Muga silk. Okay, in the Assam state. Okay. Now see this and integrate part of the tradition and culture of the state. The Muga silk, you know very well, the Muga silk and high value produced in the products of like saris, megalas and chadors. Okay, what is the importance of this Muga silk, right? This Muga silk's high value product. What ma? High value product is used in the products like saris, you know very well, for the saris, okay, for the production of saris, for the production of clothes, especially for, okay, like megalas, like some of the earrings, like chadors, etc., etc. So this is this Muga silk industry, especially for located in Assam state. That's why it's the pride of Assam state for the production of the Muga silk by using of this, especially for Muga silkworm, right? That is Antheria assamiensis, right? This is next. Sericulture stages of production. What are the stages are there actually, right? Very important thing, one by one. Okay, I think may audible, visible? Ma? Adhika?
Yes, sir.
Thank you, thank you. Wow, fantastic response. Thank you. I think you are the legend students, right? Okay, thank you very much. Sericulture stages of production. The silk moth. So what happened? I think this silkworm, you know very well, we'll discussing about later. Okay, this is the holometabola. The silkworm, which takes place in 4 stages. 4 stages are there. One is egg, second one is larva, third one is pupa, fourth one is imago. That means adult. So that's why it's holometabola. The silk moth lays eggs. Okay, the adult silk, that means adult silkworm is called moth. These silk moth lays eggs. The eggs, as it hatches into larva, larva feeds on mulberry leaves or non-mulberry silks. They are eating and osage, that means resinous, and that means oranges and what happened? Lettuce plants also, right? So the eggs hatches and larval feeds on mulberry leaves. Non-mulberry silkworms, they feed on oranges, lettuce and resinous, okay, okay, oak, etc., etc., right? When the silkworms are around about 25 days old, they are 10,000 times heavier than when they hatch. Okay, now. So in the 25 days old of these silkworms, how much time? 1,000 times heavier than when they hatch. They are now ready to spin a silk cocoon. Okay, please. Okay. Silk is produced in 2 glands. Okay, we'll discussing about later. The silk gland structure is there. We'll discussing about later of the cycle of silk, life cycle of Bombax model. The silk is produced in 2 glands. The silkworm, that is head, and there forced out a liquid from through opening called spinners. That means here silkworms, spinning glands are there and silk glands are there. So mainly 2 parts of 2 glands are there. They produces the silk. Right. So one gland to produces fibroin protein, one gland to produces so many parts of the one gland to produce sericin. Right. So especially for this spinner glands and silk glands are the which are produces the silk and 2 types of proteins. And the silk is solidified when it comes contact with the hair. Remembering one thing, when the silk which is inside the cocoon, okay, they will be liquid. That means semi-solid state, the liquid state, right? Whether the silk to be exposed to air, it should be converted as a, but I mean, solidified. It should be converted as a solid. So that is very, very important. Remembering one thing. So when we are already observed in the, especially he, she, linga, she was drinking the tree. She was drinking a tea, cup of tea, and this cocoon fell down into the tea cup of tea, hot tea. Immediately that liquid it is converted into thread. Okay, that is solid. Remembering one. And the silkworm spinning approximately 1 mile filament completely enclose itself. The cocoon about 2 or 3 days. Okay. So 1 mile of filament, 1 mile of thread should be prepared within the span of 2 or 3 days. They prepare especially for 1 mile. 1 mile is equal to 1.5 kilometers. 1 mile is equal to what, ma? 1.5 kilometers, remembering one thing. So if within 2-3 days they prepare that type of, that much of a photo silk thread. Right, due to, okay, see, due to quality of restriction, the amount of usable silk in each cocoon is small. As a result, that means 5,500 silkworms are required to produce 1 kg of silk. Remembering one thing, it's a miracle story. Very important thing, ma'am. 1 kg of silk. Remembering one thing, 1 kg of silk to be prepared purpose, we should be killed. How much silkworms? Remembering one thing, 5,500 silkworms. It's a very, that's why the silk sarees, silk clothes are very, very expensive than cotton. Very, very expensive than gold also. Right? That is important because of the highly qualified, that means highly expensive of silk thread. Right? Very, very important. That's why it is a highly employment culture, employment sericulture in India for the unemployment people. Clear? To give the employment to the unemployed peoples, right? The silk is obtained. The silk is obtained from the undamaged cocoon. If the damaged cocoon, whether from the cocoon we should be we should extract the threads from the cocoon. Okay, so that is undamaged cocoon by brushing the cocoon to find out outside end of the filament. Okay, that is for the healthy cocoon. If damaged cocoon, it is not useful. Okay, that's why very caring, very gently while we are reeling the threads. Okay, if it is a cut, that is going to what happened, ma? A very important, very damage of industry. Okay. Very much loss of that industry. That's why we are collecting thread, right? So very carefully. Okay, so right now, the silk filament are then wound and a reel. Okay, now the silk filament are done, what ma? So that means we should be damage the cocoon and to collect the threads, to reeling the threads by the process of reeling. After stiffling. Stiffling means, we'll explain. Stiffling means what happened, ma? We before the reeling process. The thread. Okay, Busta. Stifling, nothing but stifling means stifling. Remember one thing. This stifling means what happened before the collection. Stifling means what happened before the collection of these fiber. That means silk thread. Okay, the cocoons are going to boil. The cocoons are going to boil to kill the cocoons. Then after to collect the threads. That killing of cocoons is called stifling by mechanical method or chemical method. Mechanical method of boiling process. Chemical method by using of some chemical substances. Okay, that is a stifling process. Simply boiling of cocoons, to killing of the cocoons by boiling process for the production of that silk. Okay, that is a very, very important point. Okay, now let us come into the point. Sometimes ask the question. So life cycle of silkworm. What happened, ma? Life cycle of silkworm, which is asking. So long question. So very important thing. Okay, now clear. So what is the life cycle of silkworm? Remembering one thing. Okay. See, life cycle of silkworm. That means silkworm, Bombax mori, which is having very well. So that is holometabola. Hollow metabola, nothing but the silkworm completely. What happened, ma? So hollow metabola, Bombax mori. Remembering one thing. See, these the silkworm life cycle. Okay, right? It is a hollow metabola. Hollow metabola. Hollow metabola, but a life cycle it takes place. Life cycle it takes place. It has 4 stages are there. 4 stages are there. What are the 4 stages? Okay, one is egg. Okay, second one is larva. Second one is larva. Third one is pupa. That is cocoon. Okay, and imago or adult. Okay, in life cycle it takes place how much time, ma? So hollow metabola. So that means what, ma? So egg, larva, pupa, imago, and adult. So this is that's why completely it takes place life cycle. Nearly 40 to 45 days. Bombax mori life cycle takes place how much time, ma? Nearly 40 to 45 days it takes place for the whole life cycle during the life cycle of silkworm. Okay, now. Clear. So now we should be observing, remembering one. What are the ma? Egg, larva, and pupa, and imago. Let us be coming to the point. See. Okay. So the diagram is visible. Sliding. Ma.
Yes, sir.
Yes, sir, it is visible, sir.
Thank you. Thank you very much. Okay. Life cycle of silkworm. Let us how many stages? 4 stages. This one is egg, this one is larva, and this one is pupa, and this one is adult. Okay. The silk moth. How much time it takes place, ma? 45 days. How much time, ma? How much time it will take place? 45 days takes place in this life cycle of Bombax mori. Okay. See here, remembering one thing. See what happened, ma? The female moth lays many times, many tiny eggs. Nearly 400. That means 400 to 500 eggs to produces. These what happened, ma? Female moth to lays many tiny eggs on the, especially for leaves. Okay, a tiny block. That means these eggs are to be hatch into larva stage. A tiny black caterpillar hatches out of the eggs. This is a larva stage. Okay. See what happened, ma'am? Here we should observe the caterpillar. This caterpillar eats mulberry leaves. Okay. Caterpillar stage is called. Okay, now. Okay, the eggs are nearly 400 to 500 eggs to be raised from the adult moth. Okay. These very important, some terminology we should know about that. The collection of, okay, what happened, ma? Collection of eggs from this silk moth. That is one of the ball-like structure. This is the ball-like structure. Okay, that is called chandrikas. What, ma? Chandrikas. So, and after collection of these eggs. What happened, ma? So we should cover these eggs by one cloth is there, that is called canvas cloth. What, ma? That is called what, ma? Canvas cloth. Canvas cloth. Remembering one. Canvas cloth. Okay. Then after these eggs are hatches into larva, that is caterpillar. Okay, in this caterpillar, we are inserting on the mulberry leaves. We are inserting on the what, ma? Mulberry leaves, right? That is very, very important. This caterpillar is a feeding stage. It is a feeding stage. Remembering one thing, this caterpillar is a feeding stage. Okay, that is especially for mulberry leaves, and grow bigger and bigger. It goes through 4 moldings. The caterpillar in the larval stage, which takes place, okay, in that means what happened, ma? 4 moldings are takes place. How many moldings, ma? 4 moldings are takes place. Okay, in the larva to gives converted into 4 instar. That means 5 instar larvae are there. How many instar larva? 5 instar. First instar larva, second instar larva, third instar larva, fourth instar larva, fifth instar larva. It takes place how many? How many? Remembering one thing, ma? How many moldings are takes place? Come on, tell me. 4 mold. Mold nothing but egg dices. How many egg dices takes place? 4 egg dices takes place, right? So how many moldings are there? For example, for the first molding, first instar larva to second instar larva, the instar larva converted, caterpillar larva converted into second larva. Second molding, second to third instar larva should be formed. The third molding, okay, now third to fourth should be formed. Fifth molding, what happened now? Fifth instar larva, that means fourth mold, fourth molding. The fourth instar larva converted into fifth instar larva. During the weather, the larva should be enters into fifth instar larva. Fifth instar, it will be takes place 20 to 25 days. In the larva stage, completely it is a big stage. 20 to 25 days it will be takes place, right? Very, very important thing. First instar, second instar, third instar, fourth instar, fifth instar. Between the first instar larva to convert into second instar larva takes place first egg dices. That is first molding. The second instar larva converted into third instar larva by takes place of second molding. Third instar larva to convert into fourth instar larva by takes place what happened, ma? Third egg dice, the third molding. Fourth instar larva to convert it into fifth instar larva by takes place how many, ma? Which molding? That is what happened, ma? Fourth molding takes place. Okay, now clear. This is a observed. See, okay. See, already we discussed it here. See, first small size, second, third, fourth, fifth. First, second, third, fourth, fifth, right? So this is a larva is there. So whether these caterpillar, whether enters into after fourth molding, enters into fifth instar larva. In the fifth instar larva, these fifth instar larva unable to eat any feed, unable to eat any feedings, right? Remembering one thing. So then that means what happened, ma? It loses completely all feeding. That means organisms. Feeding organisms are completely loose. That means it is get ready to convert into pupa. Get ready to convert into pupa. That is very important thing. Clear? Okay. Now let us come into the point to pupa. See, you know very well. Okay. In pupa, so this is a pupa stage. Inside the cocoon, that means fifth instar larva is enters into pupa state. Inside the cocoon, the caterpillar changes into pupa state. The fifth instar larva enters into pupa state. It changes into pupa, and this pupa state, what happened, ma? So what happened, ma? It spinned releases with the help of the silk glands and threads. So to release the threads and to reeling, to spinning what happened, ma? So many threads in the cocoon. That means pupa state. The pupa is called, already told you, the pupa is called what, cocoon state. Pupa is called what, beta? Cocoon state. Remembering one thing. Okay. So these pupa state, the adult. Okay, now if, for example, for the production of silk, remembering one thing, for the production of silk, we are going to take place of what happens, stiffling process. What is stiffling? Come on, tell me. What is stiffling process? Come on, tell me, ma. What is stiffling process? Come on, tell me.
Before the collection of silk thread, the cocoons was boiling into the hot water. Then the thread will be collected. It's called stiffling process.
Very good, very good. Excellent answer. Excellent answer. Thank you, Bushra. Thank you very much. Okay. These people, whether nearly remembering one thing, we want production of silk now. So whether good qualities of pupa, good qualities of cocoons are there. That cocoons are we should be kept at the side. Okay, that cocoons are after molding converted as an adult. The adult are to using for the next generation of cycle, for the next future purpose. They kept it for the preservation, for the brooders, as I select as a brooders. Remaining all cocoons are going to take place of what happened, ma? So boiling process, that means stiffling process for the collection of the threads. Okay, this then what happened, ma? The pupa convert into again adult stage, that means for the brooder, for the future after fertilization. Okay, so then again to release eggs. again to religious texts. Completely come and tell me. So that's why the silkworm, you know very well, this silkworm, life cycle of silkworm, completely, it is a hollow metabole. Egg, larva, and pupa and adult stage. Okay, the caterpillar stage, abdomen should be formed. Okay, like mandibles are formed. Okay, where after molding, remembering one thing, fourth molding converted into fifth star larva. Fifth instar larva, right? So very important thing. This fifth instar larva unable to feed any food material. It is converted into pupa. In the pupa state, what happened, ma? By using of silk glands and spinning glands to releasing something silk threads. The silk threads are to coiled as a cocoon. But these cocoon, what happened, ma? For the brooder adults are to be changes to converted as a moth, converted as an adult. Remaining moths, remaining cocoons are going to boiling process, stiffling process for the production of silk. Okay, now this is a important about the life cycle of the silkworm. So, what is sericulture? To describe the life cycle of silkworm, it will be asking what happened, ma? Remembering one thing, long question. Here, you draw the NEET diagram. Next. So, you know very well. See. Silk, what is silk? I think, right? So silk is the queen of the textiles. Okay, queen of the textiles. Already, it is called biosteel. It is also called what, ma? Already told you, biosteel. The spells luxury, elegances, class and comfort. Mankind is always loved the simmering of fiber of the unparalleled. That means gardener. It withstood many what happened, ma? Daunting challenges from the other natural artificial fibers and yet remained that means undisputed feats. The textile since so many centuries have to be completed. The silk is a very expensive what happened, fiber then compared to artificial. Okay, these what happened, these silk which contains good qualities, high qualities like natural sheen, inherent affinity for the dyes and vibrant colors. For example, where the artificial fiber, whether we are going to dyes, should not observe. But whereas a natural silk to observe the beautiful colors. So, for example, see a blue color, orange color, pink color, different colors we should be preparing for by using of natural silks. But whereas that means artificial, we should not going to take but artificial fiber, we should not going to different colors. Okay, now that is one of the important points. So, and it is very light and weight. The silk is a very light and weight, resilience and excellent drape, etc. Excellent looking also. For the whether we are wearing, it's very happiness, very pleasure, right? That is one of the important. The silk is worn into cloth and saris in India. Silk is worn by peoples, a symbol of royalty. Those are the peoples which are wearing the saris. Those are the peoples wearing the clothes. Okay, they are looking like luxurious. They are looking like royalty, looking like a queen, looking like a king. Okay, that while attending the functions during the festivals. Okay, so for example, those people are wearing the saris. They are attending the functions and festivals. Okay, all the peoples are to observe that person. Those are the wearing the silk saris. Oh, you are looking like very pretty. You are looking like very cutie. You are gorgeous. Some people, you are royalty, looking like so something you will get something appreciation from the other side. Okay, that is a part of that's why we are very much interested to silk. Clear? So that is very important. Now we are observing, see mulberry silk, muga silk, and tassar silk. Okay, and now let us silk production in India. So many like raw silk production in India. So it is not essential for it is essential for that means CSIR level. Okay, and Karnataka. Remembering one thing, state-wise production raw silk 2017. So Karnataka. Okay, how much tons? 9,823. What 9,823. Least Maharashtra. First Karnataka. Least Maharashtra. Second Andhra Pradesh. Second Andhra Pradesh also for the sericulture in India purpose. Okay, now right. Next, we are going to graph also. We should observing on the graph. Okay, and global production of the share. Okay, in India, remembering one thing, how much percentage?